Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of the ion electron method, but specifically we're going to look at it to be balanced in an acidic solution. So the steps are fundamentally the same. The only additional steps are balancing everything that's hydrogen or oxygen. So the way we do that, we first divide into half reactions. Then we balance the atoms besides hydrogen and oxygen, so that'd be carbons, nitrogens, whatever else, sulfur. Then we balance the oxygens by adding water. Then we balance the hydrogens by adding H+, because we just introduced some new hydrogens when we added the water. But now that we added H+, what do we have to balance? Well, we have to balance the charge. The charge needs to get balanced, and we do that by adding electrons on each half reaction. And depending on which side the electrons needed to be added to, you can determine which one's undergoing oxidation. Remember, the electrons on the left is reduction, and electrons on the right is oxidation. All right? So then you balance electrons just like we did in the basic concept video. Added the half reactions, electrons should cancel out, and then cancel anything out that has the same thing on both sides. Usually you'll find some water on both sides that'll cancel, okay? So since that was kind of quick, let's go through this example here. Here we have an equation, and we want it balanced in an acidic solution. So what we do first is we come up with the two half reactions in the skeleton form. We haven't added anything to it. So we got one that's MnO4 minus and one that's MnO2. I just grouped the Mn's together, and then the sulfates get grouped together. So the first thing was to balance all the things that weren't hydrogen and oxygen right here. Okay, so if we do that, we look at the manganese here. We need to balance that. Well, it's already balanced. There's one of that here. Sulfate group, one sulfate group. So we're good to go. Everything besides hydrogen and oxygen. So then we have to balance. That was this step I just did. So the next step is to balance the oxygens by addition of water. So here you see how you have 4 oxygens and no oxygens in this manganese right here. So what we have to do is add 4 waters to make the oxygens the same. So the addition of this 4 waters now gives me 4 oxygens there, 4 oxygens there. Whereas in the next step, I have to add 1 water because there's, this is a typo. So I just noticed this should be H2SO3. Sorry about that. That 4 right there should be a 3. So we have to add 1 water here because we have a 3 for the number of oxygens on the left and a 4 right there. So what we do is we add 1 water. Now we have 4 oxygens on the left and 4 on the right. But I've just now introduced 8 hydrogens right there. Do you see that with the 4H2+, and 2 hydrogens right there. So I have to balance those. So the way I balance those is by adding H+'s. So I got to add 4 here and 8 there. Well, now I just made a charge imbalance, so I have to calculate the net charge on the left and the right of each equation. Here I have a +8 and a -1 from the MnO4 there. And we have a +2 here. So we went from a +7 to a +2. That's a difference of 5 electrons. So if I add 5 on the left side, now I have the same charge on left and right side. Now if I look at the bottom, here I have 4H+, and here I have a 2-, so that's a 2+, and it's neutral there. So I got to add 2 electrons to the right hand side. So now you understand what's going on. You can go through and cancel the electrons after you make them the same number. So what we do is we make the electrons on each half reaction have the least common multiple. So in this case, between 2 and 5, it's like finding a common denominator. You remember doing that, I'm sure. And what we do is we just take the multiples of 2, 2, 4, 6, 8, 10, until we match up with the multiples of 5, 5, 10. So the goal is to get this 5 and this 2 right here to be that 10. So the way you do that is you multiply the top equation by 2 and the bottom equation by 5. Now the electrons should be the same. If you look, see how we have 10 electrons there, 10 electrons there. So now you can add the two resulting equations to get an equation that is going to have the same number of electrons on the left and the right there. Those will cancel. But look, we got some waters also that can cancel. So subtract these 5 waters over from these 8 waters, and you'll get 3 waters left on the right side. You can't have any negative coefficients. So when we do that, these are all the things that cancel that I just told you. And I didn't tell you about the H pluses. There are H pluses on each side. So when you're done, you should have an H plus at the end. All right? It should be an acidic solution. And you should have the same charges. So we have 2 times 2 plus gives us 4 plus, and then 4 plus, and then 10 minus is negative 2, and here we have a negative 2 from this. And if you look at the elements, they should all be balanced. All right? Practice, practice, practice makes perfect. Thank you, and have a nice day. Make sure you check out the video, supplemental video, where I'm going to take this equation and balance it for basic solution. Okay?